Looking at from a graph, I think for most students, the mistakes they have here is one, you're not paying close enough attention, or you can't like see the graph good enough, or when it's on a computer, you can't actually count it because you don't have a pen. But the biggest thing is just to make sure you slow down and probably just double count. Like if you can count it twice. So once you think you have the answer, do it one more time and make sure your answers match. So in this case, for me, I know I always forget the negative when it's a negative slope because I get really excited and just keep on boogieing. So I usually will like, okay, negative. So before I even do any counting, and that's just the way my brain works, I put a negative symbol over there for my answer so I don't forget. So from dot to dot, I have 1, 2, 3, 4, 5, 6, 7, 8. So a rise of 8, and then a run of 3, and that is to the left. If you happen to choose to count up and to the left, so that also is how you know it will be negative. Or if you counted down, that would be a negative 8, and then to the right 3, which again would be negative. So it is going to be rise over run, so 8 over 3. If you could reduce that fraction, you definitely want to reduce it, but you do not need to put it as a decimal. Decimal is going to do you very minimal when it comes to actually graphing, because the rise and the run is what you need to be able to graph the line. The decimal would only come into play because we hate fractions. That's why I'm having this conversation, or most students do, in word problems, because then it would be more relative to a conversation at the rate of change. So it's usually like money or things. But as far as graphing, you do want the rise over the run, and you want to stop there. So don't turn it into a different format. You want it in a fraction format. And remember, rise is always on top, run is always on bottom. So number 2, it's going up to the right. So we know that my slope is going to be positive, so you don't need a negative line. So from dot to dot, I go up 1 over 2. Now, if you don't have dots, I highly recommend making sure, I call them stairs because they look like a staircase to me, that you have 3 stairs that match the same rise and run. With dots, it's pretty easy because you know that they've said these are good points. I'll be honest, looking at some graphs, the things that students find as good intersections, you force a little bit. So it does have to repeat at least 2 or 3 times. It should repeat forever indefinitely. But make sure your rise 1, run 2, rise 1, run 2, rise 1, run 2 happens consistently throughout the line. So the rise 1, run 2. So that's a 1/2 slope. Number 3, again, so like I was saying, if you don't have dots, rise 1, run 1, looks really good. We want to make sure it happens again. It does. And then last but not least, at least 3 times. So if it's a rise 1, run 1, this will be that whole number, and you will usually only see it in a whole number because you are required or expected to understand that all whole numbers have an imaginary 1 underneath them. So if it was a 3, then you know the rise is 3 and the run is 1. Hopefully, at some point, at least we need to get there if we're not there yet. So 4, again, this is a negative line. So I know I'm going to have a negative slope, and I know it's going to be a fraction, so I can write that much. And I challenge you, if that's all you get down, that's still better than nothing. Is working in the direction. So just don't leave them blank. Leaving them blank is the worst thing you can possibly do because you're not moving forward. You're not making progress. So from dot to dot, I have 1, 2, 3, 4, 5, 6. Rise of 6. Run of 1, 2, 3. Run of 3. And I'm going to count it one more time. So 1, 2, 3, 4, 5, 6. Run of 3, 1, 2, 3. So I got that right. 6 over 3. But you don't want to leave it 6 over 3 because we're now in high school and we have to reduce our fractions always if possible. And 6 divided by 3 is 2. So our slope is going to be that negative 2, understanding there is a 1 underneath it. So it's a rise of 2, run of 1, but in the negative direction. So whether you count down 2 to the right 1 or up 2 and to the left 1, both are allowed. You just have to make sure one of them is in the negative direction, whether it be your rise or your run, and that the line is going down, pointing towards the ground from left to right. All right, graphing. Anybody have a question from slope on graphing? Speak now or forever hold your peace. Good? Nobody say anything, so I'm assuming you're good. Okay, so slope from points. There was an equation you guys learned. So y2, x2, y1, x1, and that being, this is your x1, This is your y1. This is your x2. This is your y2. And that equation was subtraction with y's on top. So you're going to take their difference and make sure y's on top and difference, and that should give you slope. Your choice. Personally, I make a hot mess of that, especially when I have to do a lot of them, or if it's a test or a quiz or somewhere where I need to be focused on things, and I just start making a mess. So if that works for you, you have done it before, 100% use it. It is the formula for slope. So this is your slope formula. In your videos today, I believe it was, yesterday, I like to stack them, subtract them, y's on top, because it keeps it organized for me. And as I've said, organization is a huge player in getting these right. So stack them, subtract them, y on top. And that just means take that 1820, and you can write it as a coordinate, or you can space them out like I did in our previous video. 16 and 0. And I'm going to erase that comma so it doesn't look crazy. Maybe, if it'll let me. Oh, no, I'm not. I'm apparently out of whiteout, which is the saddest thing ever. There we go. And I erased the 20. Struggles on a Tuesday. And then, so stack them, subtract them, both, straight down. So 18 minus 16 is going to be 2. 20 minus 0 is going to be 20. You know this is your x column. This is your y column. Y always goes on top. So that's 20 over 2. And again, you always want to reduce. So that's going to be 10 over 1. So that means it's a rise of 10, run of 1, which you will see as 10 for your slope. Formula-wise, y2, so that's 0 minus y1 minus 20. Using my y2 minus y1. x2 minus x1. It's going to give me a negative 20 over a negative 2. And negative negative is the same thing as a positive. And so you are going to end up, once it's reduced again, with that positive 10 slope. So stack them, subtract them, y on top. You're doing the same math. Again, it is just an organizational change. But do know y2 minus y1 over x2 minus x1 is your slope formula. Both are fair game. So do whichever is going to get you the right answer the most consistently. So 16 and 13. So again, remember this is x1, y1, x2, y2. I would suggest, if you're not stacking them, subtracting them, and y on top, marking them as y1 and y2, x1 and x2. Because I've watched a lot of students do this coordinate on top, this coordinate on bottom. So you're mixing up your x's and y's. Or you start with y2 and then start with x1 on the bottom. And that does make a difference in the positive and negative when you're doing the math. So in the stack them, negative 6, negative 13 is my first coordinate. Negative 13, negative 17 is my second coordinate. We're going to subtract. And that means we got double subtraction, which hopefully we already remember and know that turns that into addition. So negative 6 plus 13 is going to be a positive 7. And then negative 13 plus 17, it's going to be a positive 4. Yep. Y is on top. X is on bottom. 4 over 7 cannot be reduced. So that is your slope, and you are done with 4 over 7 as the slope. We got 10 for that one. Do any of you guys have a preference? Do you want me to continue to do the formula and the stack, or are you okay with stack them, subtract them, and y on top? Because I'll do whatever you guys want to see as far as practicing. Okay. Number 7 I'll do as the formula. So x1, y1, x2, y2. And remember, it's going to be y2 minus y1, x2 minus x2. So that's your 12, and that's your 12. They just happen to be the same number. Y's are on top, x's are on bottom, and we're going to subtract. So negative 14 minus a positive 12 is going to give me a negative 26. 9 minus 12 gives me a negative 3. Negative, negative, we know is going to become positive. and then you just want to see if you can reduce. So if 26 is divisible by 3, then it can be reduced because 3 is a prime number. But it's not, so we can't. All we can do to clean this bad boy up and have the correct answer is keep it positive, because negative is never written that way. It would be your positive. So there it is using the formula. Again, for those of you who like stack, 12, 12, 9, negative 14, minus, so 9 minus 12 is going to give me, 12 minus 9 is going to give me a positive 3. 12 minus, which turns this into a plus, is going to be 26. We know y is second, so 26 goes on top of 3, just like we got before in our formula. So I have x1, y1, x1, x2, y2. Told you this is not what I'm good at. 4, negative 5, starting with our second coordinate, 2, 13, minus. So 4 minus 2 is going to give me 2. Negative 15 minus 13 is going to give me a negative 18. So we have a positive and a negative, so this is going to stay negative. We do want to check and see if 2 divided by 18 can be reduced. Does 2 go into 18? It does, by 9. So we're going to have a negative, and I just put it to the top so you can see it. Negative 1, 9. So it's going to be a negative slope. So that line, when you graph it, is going to be headed in this direction, but a lot less steep than that because it's going to be down 1 over 9. So it's going to be very shallow, so not a high hill going down. So negative 1 over 9 should be your slope for that one. Any more questions? Any questions that you have for me for solving from 2 points? And in the videos from Monday, I did show that you can graph it as well and then count it if you're pretty good at plotting points. I would say be careful because some people get lost on a graph plotting points, especially when they're big. Like 12, 12 is easy to lose. And your lines, unless you use a good straight edge, aren't straight, so they don't cross through intersections, and it makes it a little complicated as far as graphing and counting the rise and run. So you do want to make sure that you can solve it, but it's a backup plan for graphing or for making sure you have the right answer. Everybody okay? Can I keep moving? All right, still moving. So this is slope-intercept form. So y equals mx plus b is considered slope-intercept form. Slope is the m. B is your y-intercept, which we're pushing a little bit further for some more vocabulary, but might as well start now. Y and x. So x and y, and I want you to think of all of these things as separate people. So I have y, I have m, I have x, and I have b. mx, they are attached by multiplication, but they are two different numbers. They're two different things. X and y is a coordinate, any coordinate that might fall on that line. So it has a job, and its job is not slope, and its job is not y-intercept. Its job is just that I exist on this line. So looking at number 9, y equals mx plus b. If I'm looking at these numbers and how they line up, m is the number in front of x. It's the coefficient attached to x. So when looking at slope-intercept form, 3/5 is our slope. And you're out. As long as it is in y equals mx plus b form. That is it. And they could easily ask you, what is the y-intercept? What is the starting point? Where did this graph start when it's on the graph? If it was a word problem, how many, I'm trying to think of a linear one. How many apples did you start with? 1, because that's your starting point or y-intercept. The gain, because this is a positive slope, so you do want to start looking and deciding again if it's positive or negative, because that matters for word problems at the end, especially because it'll help you decipher through those a little more easily. That means it is going to be a gain. That line is going to increase to the right, so go up to the right if you're reading from left to right. So as x values increase, so that's going towards positive infinity, your y values are also going to increase. That's what makes the line go up. So looking at number 10, y equals mx plus b. We're just looking for slope today. So we're looking for our m, which is right there in front of the x. So our slope is 2. If I asked you for the run, it would be 1, because remember, all whole numbers have an imaginary 1 underneath it when we're discussing rise over run, and that's for graphing it on a graph. So our slope is 2, our rise is 2, our run is 1. And then just because you showed up to class and for some extra knowledge to make your life easier, in the future, y-intercept will be 5 because it's the constant in the equation. So your rate of change is also your slope. So rate of change might be a word that you're going to see when they're still asking for slope. Rate of change, slope, rise, run are all discussing that coefficient that is attached to x when in slope-intercept form. So when in y equals mx plus b form. So y equals mx plus b for number 11. We're looking for our m value for slope, and our m value, or our coefficient of x, is going to be 8. Coefficient of x is another verbiage where they're asking you for the same number in this equation. So the one thing about math 1 I think is kind of interesting is most of this math, you've seen it before, you've done it before. They're just adding a ton of vocabulary and a ton of different ways to ask for the same thing. So they're coming from all different directions, but you have the skills already. You learned or started to learn them in 6th, 7th, and 8th, but definitely in 8th grade math. Hopefully you've gotten enough of it and can remember some of this. But again, the vocabulary in math 1 is a lot more vast. So they're going to ask it in different ways. So if you run into a question and you're not sure what it's asking you for, that's when you want to email me, send me a screenshot, or text me so we can slowly get over that portion, because the wording is a lot more intense for math 1 than math or 8th grade math. So we're looking for m. In this case, we have a negative 3 over 2, which means our rise is a negative 3. Our run is 2. So this line, again, is negative, is going to be going this way from left to right. It's going to go down. So as x increases, that means as I'm reading the x-axis going to the right, y is going to decrease, which makes this line go down. All right, questions before I keep moving? All right, so so this is standard form, where x and y are on the same side. This is standard form. For math 1, except for systems and solving by elimination, literally standard form does not help you do very much. Standard form is probably the worst way you can get a linear formula handed to you to then start asking questions about it. It is no different than literal equations or solving multi-step equations. So you just have to find the pattern, which means do enough of them, or write out the steps and follow the steps. So your great divide, we want y by itself because we're going to switch it to y equals mx plus b form, which is slope-intercept form. So we want y by itself. So this is the guy we want by itself. So the 3x is the first thing we can move. In this case, we want to subtract because it's positive. So your first step would be, I guess, theoretically, to identify your y, like see it and see where it is, but move mx to other side. Whatever is going to be addition or subtraction for sure. And then I have, so it's a positive 4y equals 16 minus 3x. You want to look at this 4. Again, it's attached to y by multiplication. So we're going to take the inverse of multiplication and divide. And probably just want to write them as 2 separate fractions, because remember, we have a rise and a run and then a y-intercept. So they need to be written as separates because it will help you to graph along the way, and it will help you answer questions about y-intercepts, starting points, rise, run, what's the rate of change, things like that. So if you practice it in that form, you will be set up to answer more styles of questions. So move mx to the other side and then divide by coefficient. So whatever is attached to y. So get y by itself is what I mean by that. So whatever's in front of y, you're going to divide. And most every one of these are exactly the same. The numbers are just different. And then so from here, I now have y equals, and I'm going to rewrite it so we can see what I meant by writing them separate. You're going to just simplify. Like check your fractions and make sure they can't get a little more, neater. Whole numbers. Your y-intercept, you ideally would like it to be a decimal, because if you have to graph it, if I told you on a number line to go find 1.75, it's not as, 3 over 2, which is 1.5. If I said go find 3 over 2, you're going to, not that you can't do it, but it's not going to be as easy. So your y-intercepts are better as decimals. Your slope is better as fraction in the future for when we start graphing them. So 16 divided by 4 does get better. That is going to be a 4. 3 over 4 does not get better. So you're done. Now, you may or may not see it in this order. It will probably be in the order y equals negative 3 over 4x. So this line is going down, and then plus 4. So it's going to start at 4. You're going to draw a dot at 0, 4 on the y-axis. Go down 3 and then to the right 4. Down 3 and to the right 4. And that line's going to go down to the left. Not harping too much right this second on the graphing part, just adding because you're present and we don't get to meet again until Thursday. So we're going to get y by itself. So we're going to move mx. So move 7x. I'm going to subtract again because it is positive. And so at that point we have negative 4y. Be careful, be careful, be careful not to lose that negative. So I can write negative 7x minus 12 because that's a negative 12. And that's already putting it in the y equals mx plus b form. We need to get the y by itself. There's a negative 4 there. So I'm going to divide all of these by negative 4. So y equals, negative and negative means it's going to become a positive. 7 and 4 don't reduce though. So it's still going to be a rise of 7, run of 4. Negative, negative again is going to be a positive. 12 is divisible by 4. So that's by a positive 3 because 3 times 4 is 12. If this is on calculator active, I would love it if you could type that in and make sure you're right. You've missed a lot of great classes of me doing some really bad multiplication in my Math 3 and Math 4 class lately. And if you have the calculator, use it. If it's inactive, do the best you can. That's all you can do. That's all anybody can ask. So in this case, our slope is 7 over 4. Our previous slope was negative 3 over 4. Looking at number 15. So line of great divide, identify where our y is and what needs to move. So that x on the outside needs to move. The coefficient is an imaginary 1. So you can write negative 1x or just minus x, same thing, to move it to the other side. So we have a positive y equals a negative x plus 1. In this case, there's nothing still attached to the y, so you are done. And to answer what is the slope, you're looking at what's in front of the x. That's an imaginary 1, and there's a negative. So our slope is a negative 1, which means the rise is negative 1. The run would be a positive 1 or vice versa. You can flip them, and they'll both do the same thing. So it could, if you said rise was positive 1, you just need to know that the run is negative 1 because the end fraction has to be a negative 1 when simplified. Number 16, divide. You have a negative y. Make sure this is where, if I were you, anytime you see a number without or a variable without a number in front of it, some of us, it's good practice just to put a 1 so you don't lose it and don't think it's not a thing. So negative 3x, to move it, we subtracted because that was a positive 3x. And that has a negative 1y equals a negative 3x minus 4, because that's a negative 4. Y is not by itself yet. We're going to divide everything by a negative 1. And hopefully you remember that if we divide everything by a negative 1, all that really does is change the symbol or the sign. So it now becomes positive or negative if it was positive. So y is going to equal negative negative gives me a positive 3x. and negative negative gives me a positive 4. And remember, all numbers have an imaginary 1 underneath them, but we don't write them there. We may use them in solving, like to get down to the end, but at the end, those 1s underneath whole numbers go away. So the slope for number 16 is a positive 3, which means the rise is 3, and the run is 1. Because again, remember, there's an imaginary 1 under all whole numbers in general, but especially for slope. So number 17 is a totally different case. There's no x. And this is just an introduction to what you're going to get into in the next couple of days. Again, y equals. So Hoy-Vux is the best cheat I've ever heard. So it's horizontal, 0 slope, y equals equation. So this is a horizontal line, which means the slope is 0. So y equals is a horizontal line with a 0 slope. So if I'm going this way, walking that way horizontally, it has no slope. It has no rise and it has no run. No rise, no run, 0, 0. And if you think actually about rise and run, if this was y equals negative 4 is fine. So there's no rise because it didn't go up. And your run would theoretically be negative 4. If you type in 0 divided by negative 4 in your calculator, you're going to get 0. Vux is vertical line, undefined slope, and then it's going to be an x equals equation. So if we had x equals 2 and we want to know what the slope is, because it's x equal and there's no y, there's no b, there's no m, it is an undefined slope. So vertical is up and down. And if it's x equals 2, that means the rise is going to be 2. The run is going to be 0. Type that in your calculator and you're going to get an error. You cannot divide by 0. So that's why this is undefined. So this is your mathematical y. Hoy-Vux is a great cheat to keep a lot of things very, very compact and answer a lot of questions with one thing to learn. So Hoy-Vux, H-O-Y equals, Vux, V-U-X equals. And again, that's coming in the next day or two. Last but not least, we have that negative 1y. We have a 1x. We need to move that x. We're going to subtract 1x from both sides, which is going to give me a negative 1y equals a negative 1x minus 5. Y is not by itself yet, so we're going to divide by negative 1. And that's going to leave me with y equals negative negative becomes a positive. So it's going to be 1x or just an x. If you write it with 1x, that's fine. Negative 5 divided by negative 1 gives me a positive 5. And so the slope of this line is at 1. So we have a slope of 1, which means it's a rise of 1, run of 1. It's positive, which means when it was graphed on a piece of paper or on a coordinate plane, it is going to go up to the right when reading from left to right.